Hi everyone, this is Yukabuka and welcome to my home on YouTube. In this video we will continue our dive into kobjects in the Linux kernel, and this is the fifth video in the series. Okay, so we will continue from where we left off in the previous video and start looking at ktypes and release methods. One important thing that is still missing from the discussion is what happens to a kobject when its reference count reaches 0. Okay, the code which created the kobject generally does not know when that will happen. If it did, there would be little point in using a kobject in the first place. Right. So the users of kobject would not know when the reference count of the kobject reaches 0, and that's the whole point of having a kobject. I see. Okay. Even predictable object life cycles become more complicated when sysfs is brought in, as other portions of the kernel can get a reference on any kobject that is registered in the system. Got it. The end result is that a structure protected by kobject cannot be freed before its reference count goes to 0. The reference count is not under the direct control of the code which created the kobject. Right. So that code must be notified asynchronously whenever the last reference to its kobjects goes away. Got it. Once you register your kobject via kadd, you must never use kfree to free it directly. Yes, we have seen that this is mentioned over and over again as a comment to the function kobject init, kobject add, and so on. The only safe way is to use kobject put. It is a good practice to always use kobject put after kobject init to avoid errors creeping in. That is a bit strange. For example, a kobject add would increment the reference count and a kobject put would decrement it. So why would you want to issue a kobject put right after the init? Let's take a look at what kobject put does. Kobject put. Okay, so it first checks if the kobject is valid, and if it has been initialized. If it hasn't been initialized, it prints out a warning. And then calls the kref put. That is, if it hasn't been initialized. So this is a different line. It's just so if it hasn't been initialized, it prints out the warning. But in either case, it eventually does call kref put on the kref value inside kobject. Right. And the kref is of type struct kref. Makes sense. Interesting. So why would they do this though? Kref put eventually goes to a decrement and test. Let's have a look at what kref put does. It seems to do something more than just decrement the reference count. What it does is it calls decrement and test on the kref ref count, and depending on what value kref decrement and test returns, it does a release on the kref and returns 1, or it returns a 0. So we would need to take a look at what ref count dec and test does. Let's take a look at that. I see two references to this function. Ref count sub and test, atomic decrement and test. I will try looking at this. Atomic decrement and test. Seems to perform an atomic decrement and a return of the value. Okay, so what it does is, we can verify that. Atomic dec return is effectively just subtracting the value 1 from V and then just returning that value. So what atomic decrement and test does is it decrements the value by 1 and checks if it is equal to 0. So in this case, this function, let's go back one more step. If this value upon decrementing returns a 0, then you go inside this. Then you get inside this and then you return 1. Else you return a 0. Now what does release do? So release is a function pointer that is passed into this. Okay, so let's go back and look at this. Okay, so we pass a function pointer into kref put, and that function pointer is the one that is called. So what does that function do anyway? It manages to get the k object using the kref, and if the debug configuration is not set, it does a k object cleanup. Interesting. I wonder why this happens though, because so the question is how, let's take one more quick look at how k object init deals with the kref. Let's look at how it initializes that. K object init, and if you go here, we can see that there is a function here, init internal, where you have an initialization happening. So if you look at the init, the way it does the initialization is by setting the count to 1. Okay, so the value is set to 1 at that point, and when you do a k object put, that value is reduced by 1, and if the value is a 0, then the function pointer that is passed in will be called, and in this case the function pointer or the function that is passed in will free the k object and release the memory. That's what it does. Okay, but I don't understand why calling a k object init followed by a k object put is a great idea. Once you register the k object via add, you must never use kfree directly. You must only use it. The only safe way is to use k object put. It is a good practice to always use k object put after k object init to avoid errors creeping in. Perhaps what this line means is that k object put is only supposed to be used eventually after k object init as opposed to right after k object init. Perhaps that is what it means. I'm not quite sure. I could try asking on Stack Overflow. The next one is This notification is done through the kobject's release method. Okay, yes, we did see that. Usually we have a method of the form void myObjectRelease of struct kobject. You get a pointer using container of, and then you do a k-free of my object. Okay. Right, so the kobject has a release method, but I don't think that's what's being referred to over here. Does the kobject itself have a release function pointer within it? Yes, it does. But that does not seem to be a function pointer. It's a struct of type delayed work. What this says is once you register your, oh no, sorry. This notification is done in the form of kobject's release. What notification are they referring to? Yes, so this is what they're referring to. The code must be notified asynchronously whenever the last reference of the kobject goes away. Okay, so what they are describing here is the mechanism by which the container of a kobject is notified when the kobject's reference is set to 0. So in order to do that, it is somehow using the kobject's release method, but the kobject's release does not seem to be a function pointer over here. I can take a quick look at what struct delayed work consists of. It consists of a work struct, a timer list, a work queue struct, and a CPU. So perhaps this is a way of creating a delayed task to execute eventually. Not sure. In this example, what they say is that the release method eventually calls this function, and we have some way of saying that this is the function that needs to be called, and that takes care of freeing the object. One important point cannot be overstated. Every kobject must have a release method, and the kobject must persist in a consistent state until that method is called. If these constraints are not met, the code is flawed. Note that the kernel will warn you if you forget to provide a release method. Do not try to get rid of this warning by providing an empty release function. Got it. So you need to provide a release method. I'm not sure which structure they're referring to. I don't think they're referring to the struct delayed work release. Let's keep reading. Note the name of the kobject is available in the release function, but it must not be changed within this callback. Right. Otherwise, there will be a memory leak in the kobject core, which makes people unhappy. Got it. Interestingly, the release method is not stored in the kobject itself. Instead, it is associated within the ktype. Aha. So that's why we were unable to find the release method. So let us introduce the struct kobject type. So struct kobject has a release pointer and a few other pointers and function pointers. Okay, so the kobject type's release method needs to be set. The curious thing is, I don't believe we have seen any code either inside kobject init or kobject add that actually sets this function pointer. So perhaps we will see this somewhere close by. This structure is used to describe a particular type of kobject, or more correctly, of containing object. Got it. Every kobject needs to have an associated kobject type structure, and a pointer to that structure must be specified when you call kobject init or kobject init and add. Right, let me just take a quick look at kobject init. Right, so as you can see, there are two arguments to this function. It's the kobject and the ktype. Okay. The other two fields, sysfsops and default attrs, control how objects of this type are represented in sysfs, and that is beyond the scope of this document. Okay. The default attrs pointer is a list of default attributes that will be automatically created for any kobject that is registered within this ktype. Yes, we have seen this before, and I believe we saw that in the part where the sysfs directory is being created and files are added inside it for each of those default attributes. Sounds good. So let's see, is there anything else that we need to investigate? So at this point, I believe it's fine to assume that the kobject type will be created by the caller of the kobject init function, which is also probably the code responsible for creating the container that contains the kobject. And so that is the code that will be responsible to set the release function pointer. Okay, that's it for this video. In the next video, we will look at ksets. Alright, if you enjoyed the video, press like and subscribe.